Getting to look at our quadratic formula. The quadratic formula, what it helps us do is solve standard form quadratics for their roots. It kind of helps us do what we've done with factoring. It helps us do what we do with graphing. So with any quadratic, you end up getting a parabola when it's graphed. Factoring it is a way to rewrite it from standard form down into two binomial pairs that say something x plus minus whatever those binomials happen to be. There's no direct correlation, like this doesn't become like a and a or anything like that. Graphing gives us the whole picture so we can see it visually. But quadratic formula, what it does is it's going to tell us what these two roots are. Right there and right there. The thing is, why we have all the other methods, quadratic formula, all it does is give us that. For instance, the red and the green parabolas have the exact same roots. The quadratic formula will give us the exact same answer, but that's why factoring and graphing still have their place. It tells us what else is happening with the quadratic. So we have some of our vocab from the unit. Quadratic equation. Remember, that's anything with an x squared. Parabola, that's the shape of the graph. Vertex, that's the very bottom or the very top of our parabolas here. Like so. X-intercepts, those are the roots. Y-intercept, that's just where it crosses the y-axis. And of course, our axis of symmetry. Kind of our visual picture. So here are the roots, there and there. Vertex, vertex, y-intercept. This red one, the y-intercept is off the page, and there aren't any x-intercepts. So the types of roots that we can see with parabolas, if I draw three graphs here, one, our parabola clearly crosses the x-axis at two places. That's two real roots. If our parabola just comes down, boop, touches the x-axis and turns around, so our vertex is right there. That's known as a double root. And then if our parabola doesn't cross at all, that's called no real roots. All of these, of course, can be our upside down parabolas as well. The same thing is true. Here is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. It looks more complicated than it actually is. Truthfully, this is the only variable in the entire problem. B, A, and C are all the numbers that we get from our standard form quadratic. The song goes x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And using this will help us find the roots to any standard form quadratic. So let's take a look. This one, we could solve it by factoring. If we factor, we take 1 times 6. I need two numbers that multiply 6 to give us to 7. It's 1 and 6. We'd break it down. We get our two binomials, x plus 1, x plus 6. We use our zero product property. Like this. So x is negative 1 or negative 6. Factoring is definitely the quicker method. But let's say we aren't quite 100% sure with factoring anymore. It's been a while. Or we're not 100% sure if this is factorable. We can use the quadratic formula. So the first thing we're going to do is we're going to write down the formula. Negative b plus or minus the square root b squared minus 4ac all over 2a. And then we're going to plug in all of our values. A is 1, B is 7, C is 6. So we've got negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 6 all over 2 times 1. This step is very important. We might think, oh, just type it into the calculator, it's fine. But this minus sign right here causes more trouble than it's worth. One, we read it as a minus. I like to just include it over here in the multiplication aspect, so it's a negative 4. That way I don't have to worry about if I have a minus, a negative answer. I just include it directly. So what that means is, when I get to that part, I'll show you. So we have the negative 7 still there, plus or minus the square root of 49. So what I typically do on these problems, when I look right here, I'm going to take negative 4 times 1, so that's negative 4. Negative 4 times 6 is negative 24, and I write negative 24 all over 2. X equals, of course. So then we have negative 7 plus or minus the square root of 25 over 2. We can take the square root of 25, so I have negative 7 plus or minus, oops, I got rid of the square root. Okay, well, my eraser decided to kind of go on a rampage here. It's at this stage right here where we're going to get our two answers. Remember, because a quadratic says x squared, there's always two answers. Negative 7 plus 5 over 2 and negative 7 minus 5 over 2. So x is either negative 2 over 2 or negative 1. Or negative 12 over 2, which is negative 6. So let's take a look at one that looks like this. This one ends up being a double root, I'll tell you off the bat. Let's see what those look like. So we've got x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We plug it in, so we get negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 9 all over 2 times 1. Go through, we simplify what's underneath our radical. That gives us 36 minus 36 all over 2. So what happens is we end up getting a negative 6 plus or minus the square root of 0 over 2. Well, the square root of 0 is just 0. Negative 6 plus or minus is 0, so this just goes away. So there's our double root, negative 3. If your quadratic doesn't equal 0, you have to make it equal 0. So we're going to subtract 10 from both sides. From here, we can check to see if it's factorable or not and try to use any of our techniques. It's not factorable, so the only other method we have to solve it is the quadratic formula. So I'm going to write it down over here and begin the process. So we get negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 14 all over 2 times 1. Negative, or 4 squared, I'm sorry, I was looking at that one. 16. Negative 4 times 1 is negative 4. Negative 4 times negative 14, I believe, is 56. Yep. But that's a positive 56 all over 2. Combine what we have inside our square root. And since 72 is not perfect, we can't take and get a whole number. We don't want to use a decimal. So this is where we're going to use that simplifying technique that we learned on Friday. I can break 72 into 36 times 2. The square root of 36 gives us 6, and the 2 is still trapped underneath the radical. The final thing that we do when we simplify these quadratics is we take a look at the numbers that are outside of all of the radicals. So the 2 is not included here, this root 2. The square root protects it. And if there's anything in common with those 3 numbers, we simplify it further. They all share a 2 in common. So we get negative 2 plus or minus 3 root 2 for our answers. Both the plus and the minus versions are listed here. You are welcome to write it separately if you want, but you do not have to. Last example I want to look at for this video is this one. Again, first things first, make it equal 0. We start to set up our quadratic formula. We get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We get negative 5 plus or minus the square root of 5 squared minus 4 times 3 times 4 all over 2 times 3. That negative 5 is still there. We get 25 minus, well, 4 times 3 times 4, negative 48. But what we see is we end up getting a negative 23 underneath the radical. You cannot have a negative underneath your square root symbol. With that negative right there, that tells us that there are no real roots. To help you kind of see it, if I was to take the square root of 16, my 2 answers would be positive 4 and negative 4. Due to the fact that 4 times 4 and negative 4 times negative 4 both give us 16. But if it was a negative 16, there's no way to make these 2 numbers be identical and still get a negative 16. They are not possible negative square roots. Which brings us our no real root solution.